In this lesson, we'll be focusing on the property page and taking another look at how it's grown over time. It's helpful to stop and look at your code with fresh eyes every once in a while, since sometimes what made sense when you started the code may not make sense now. We do this a lot at work, especially on larger projects that have a long history. With this project, we started with one API, and since the code was almost duplicate, we mostly just copied and pasted it for the next two APIs. No big deal, right? Let me point something out. Go to your browser and open up the home page. Open up DevTools and head on over to the Network tab. Let's filter by Algolia and then select Fast 3G. Then click on a property. Take a look at the waterfall to the right. Notice how each API has to wait for the one above it to complete? This is horrible for performance. So what happened? The problem is how we use async await. Remember that await won't execute any code below it until the promise is resolved from the thing it's waiting on. Well, this includes other awaits too. Each API call is literally waiting for the one above it. What we need is a way to run all API calls at the same time and only continue when they're all done. Thankfully, JavaScript has just a solution: promise.all. The promise.all method takes an iterable of promises, that is, something that it can loop through. It returns a single promise that resolves to an array of results in the same order as the input promises. Let's refactor our code using promise.all. Since promise.all returns an array of results, let's define a new constant called responses. Then set it equal to promise.all with an empty array inside it. We still want to await it. Now inside the array, insert each of our API calls. Great! Now we have to detect errors. Since our API plugin already takes care of network errors and makes sure everything returns a promise, all we have to do is look for a response where OK is false. Create a constant called bad response. Since responses is an array, we can use the find method to return the first error we find. Find takes a callback function that evaluates the current iteration and returns true or false. If the callback returns true, the function exits and returns the current item. Use responses.find and an anonymous function to return true when response is not okay. Now we can add an if statement after that. If bad response is something, then use the response object and trigger an error like we did before. Great! Now we'll see an error page if any of the three API calls has an error. There is a chance there is more than one error, but at this point I'll just keep it simple, as usually the first error is sufficient. At this point, all APIs should have data since we just handled the errors. Now, just update the return statement using the index of responses. And save. Let's see this in action. Head on over to your browser and go back to the home page. Clear your network tab and keep the fast 3G throttle. Click on a different property and let's focus on the waterfall graph to the right. Much better. See how they all start at the same time now? Perfect. I should mention this also improved time to first byte on this page as well. That's the time it takes the server to start sending data to the browser the first time someone hits the page. It's now 3 times faster, since we're only waiting on the slowest single API response instead of the combined time of all three. This is a great example of how a little attention to detail and some fresh eyes can produce huge gains. Code is always changing, So don't be attached to it. Let it grow organically, and if needed, make adjustments.